Hey guys, welcome to another Chemistry 151 GLA. James here, and today we're going to cover the chart in GLA number 3. So I went ahead and I filled in the ions portion of the chart already. There is a list of common ions that I'd recommend you knowing. If you don't know where to find these ions, I would recommend asking your professor for them. They should have a handout that they can give to you. Common ions will usually show up on your test or your exam, so it's important to be familiar with those. But jumping right into it, let's go ahead and start. Potassium has a +1 charge. Acetate has a -1 charge, so when potassium and acetate bond with each other, the overall net charge will be equal to 0. So we can write this first compound as just KC2H3O2. Now sulfide has a -2 charge. So to get the overall charge on the compound equal to 0, we're going to need 2 potassiums. Because if we have 2 potassiums, that means we have a +2 charge coming from potassium, and the 2- charge on the sulfide will cancel each other out, and the overall net charge will be equal to 0. Much like sulfide, carbonate has a 2- charge as well. So we're going to need 2 potassiums to bond with a single carbonate ion as well to make that 0 charge that we're looking for. For potassium phosphate, we need 3 potassiums to bond to the 1 phosphate ion in order for the charges to balance. Ammonium is a lot like potassium. It has a +1 charge, so when ammonium bonds to chloride, it's going to be in a 1-to-1 ratio again. Same thing with ammonium acetate. We have NH4C2H3O2. For ammonium sulfide, we're going to need 2 ammonium ions for the 1 sulfide. Same thing for ammonium carbonate. We need 2 of the ammonium ions to bond to the 1 carbonate ion to give us that overall charge of 0. And for ammonium phosphate, we're going to need 3 of them. Now, copper usually forms a +1 or +2 charge. In this case, we're going to be using the copper that has a +2 charge. You know it has a +2 charge because it has this Roman numeral right here beside it. If this had said copper 1, then we'll know we'll be using the copper with a +1 charge. But here we're using +2. So for copper 2 and chloride to bond with each other, we'll have 1 copper bonding to 2 chlorides. For copper 2 acetate, same thing, we'll have 1 copper for 2 acetate molecules. Because copper has a +2 and sulfide has a -2, copper 2 sulfide will just look like that. Same thing with copper 2 carbonate. We have CuCO3. Now, copper 2 phosphate is a little bit tricky. What we can do here is we can take the charge on the copper and make it the subscript on the phosphate, and we can take the charge on the phosphate and make it the subscript on the copper to balance out the charges. So if phosphate has a 3- charge, we can say that we would have 3 coppers bonding to a PO4. And because copper has the +2 charge, we'll make it the subscript of the phosphate. And what that does is, if copper itself has a +2 charge and you have 3 of them, you know the overall charge here is going to be +6. If phosphate has a 3- charge and you have 2 of them, you know the charge over here will be -6 as well. And so overall, that's just going to automatically balance out the 2 charges. Next, we have lead-4 chloride. Lead has the +4 charge, so we're going to need 4 chlorides to balance that out. Here we're going to need 4 acetates. For lead 4 sulfide, we'll have 1 lead bonding to 2 sulfides. Same thing with lead 4 carbonate. We'll have 1 lead molecule bonding to 2 carbonate ions. And for lead 4 phosphate, we have Pb, PO4. And so like we did before, we'll take the charge that's on the phosphate and make it the subscript of the lead. And then we'll take the charge on the lead and make it the subscript for the phosphate. And like we did before, if this has a +4 charge and you have 3 of them, that means you have a total of +12. If phosphate is -3 and you have 4 of them, that means this is -12. And so these two will cancel each other out, and the overall charge on this molecule will be equal to 0. So that's how you do the chart on GLA number 3. I'll see you guys next time.